If yours are after much stuffing and racking my brain here, how am I going to do this? Well, yeah, that's kind of what I've come up with. Put you, say, an apple or an orange in there, pour this, that's my switch. Needs more refining though. I haven't got enough bloody resources or materials for this sort of a proper switch setup. Definitely can't use an SCR with this, no way. The SCR would be blown to smithereens. Yeah, it still needs a bit of refining here, but if I had some proper bus bars, I would have done a better job. When this guy got the capacitors off, gets back to me, his brother gets bloody does demolitions and stuff, so hopefully one of these days he'll accumulate some more stuff like that, including some big bus bars. Yeah, it's not the best sort of switch, but that will do. I'll have to refine it a bit more to get a bit of a better contact on this side. The whole idea is to have a bit of string. I'll pull a bit of string. I'll be right away over here somewhere. Just pull the string and that will blow the food up. I don't want to be near this thing. Then I'll have to rig up some other thing to short this out. It's a shorting strap, but most of the charge will be gone when I blow an apple up. But to save the, I have to somehow have a little thing from my ZVS here, cover it up. You just disconnect it. Yeah, I put a shorting strap on it because I haven't got a yeah, 5 minutes. It takes 5 minutes to the internal discharge resistor inside these capacitors to bleed these things down. So that's this most part of it done. Using some flattened out copper pipe, I've tried to get as much chunky of a chunky path from the capacitors to the subject as I can. Hopefully there's not going to be too much losses through this. I guess I'll give it a test, I reckon. I'll see how it goes. It'll probably go on here. Find somewhere to put this. Yeah, I've got to refine this shorting strap idea out there. Let's get some string and give it a test. I'll get my ZVS out and get an apple or something to test it. Okay, so now that's my supporting wood. I would love to have used PVC, but haven't got any decent bits of PVC pipe laying around. So it's going to have to be wood for now. Once that starts to get juiced up and wet, it's going to be a conductive path to the capacitors, so that's going to have to be replaced with a bit of PVC pipe eventually. This whole switch idea will have to be redone. But yeah, I lack proper resources, so here's the best I can come up with. I've calculated it to be 130, charging this bank to 30 kV, be about 122,500 joules, I think. Somewhere around there, so over 100 kilojoules. That is ridiculously, ridiculously powerful. If I charge these at 40 kV, I think it'd be almost 200,000 or so kilojoules. So 200 kilojoules, I mean, 200,000 kilojoules. 200 kilojoules. So yeah, pretty bloody yeah, these are gonna be. And for that sort of power, this is going to have to be refined eventually, but we'll see how this little setup here goes. And a bit of a mistake here, I should have put that switch on this side. They will both all get charged evenly and discharged evenly and equally by putting that here. But now the idiot light comes on. So I'm going to charge one of the capacitors and dump it into this capacitor, and that. Not going to work very good that way. I shagged it up. Gonna have to find some more copper pipe and send them make another bus bar. Damn it, what an effort I put into it now, I realise. Should have been here. Another bit of bracket to come off here, and the switch should have been here. But then this thing wouldn't have been secured, so I've still got some refining to do. Anyway, let's see how this works out. See if I can put two lead there, charge there. Another way there and there to charge, that one. Yeah, we'll see how that works. Hopefully it can vaporise this apple, make apple juice. Yeah, I just had another thing come to mind. I should have bloody realised. You're supposed to use dissimilar metals not the same, otherwise that's why they weld together. So I should put a chunk of aluminium in there on my switch, and that won't weld. It's a dissimilar metal to copper. It's not quite as conductive, but it won't weld. Steel might, but aluminium's the next best thing I could use. So being two dissimilar metals, I won't have that welding together problem. Yeah, should have paid more attention in the first place anyway. I should put the switch here, but then this is going to be holding on by one electrode. So hook up there, got positive in there, go and charging that one up, negative on this one, going through that charge and through the apple to charge this one. But that's not seeing positive. So really only that one capacitor is charging. And I dumped the charge on that into this one. Just shorted out in the apple, which yeah, this took all the power. So yeah, I have to redesign my switch and bus bar setup, I think. That was a good start there. Anyway, viewers, so now I'm going to revert back to the old ways. This is just the easier way to do it. Until I get some proper bus bars for this thing. Move the camera right back. The last short's facing away from me, so I'm not going to get full of pear and crap. That pear's a bit old, so let's see how we can compare the results, should we? How this compares to the apple. I'm going to put lots and lots and lots of pears through that pear. Alright. Let's see how this goes. Hopefully the battery's hot up this time. Like there. Charging. Charging. Car's starting to go down. 51. No, didn't work. Oh, it didn't work. Hey, I smelt the pear fire though. ZPS is isolated, it is disconnected. Okay, short that out. That's shorted out. Leave that there to short out. Yeah, that pear hasn't got enough juice in it. Let's try the banana next. See if that does nothing. I think I want a mandarin vaporising this didn't. This doesn't have as much sugar in it. It did definitely pass the current though. Bit warm too. Let's try the bananas. They got a lot of potassium in them, so hopefully they're conductive enough. Let's try that. I guess not all fruits, when they're in their right freshness or too ripe, or if they're too ripe, they won't work. So I guess it has to be fresh fruit. Let's try the banana. This banana's a bit overripe. Let's see if that works. The batteries could be a bit weak actually. Yep, there we go, starting to charge up. That's it on. Yep, that worked. Disconnect. Discharge. Okay, that's discharged. I thought so, it's the fruit. Yeah. That was about, I reckon, a quarter of the way charged this back. Okay, so yes, it's unplugged, that's shorted out, it's safe to proceed. Yeah. There you go, you got to experiment with different fruits. A lot of the pear still had a lot of juice in it. It obviously wasn't conductive enough. Interesting. Yeah. That blast shield helps. Let's get a close look at the carnage. Can't compare that to the pear. Yeah. I guess some juices or some fruits are going to be more conductive than others. My estimation was right. A lot of potassium in the banana. Potassium's a type of metal, so it obviously conducted okay. Now I could have let this thing sit for longer, but those batteries are just, well, this one in particular is weak. I've got a crossover, it only charges to about 16 volts tops. That one is still okay. This one is letting it down, so I need to get a good beefy 36 volt power supply, more than capable of supplying enough amps to run this thing properly. The batteries are let down. Delish. I got one more banana there. Might let it charge for longer. Hopefully that battery holds up. Got down to about here, 6 amps. So I started off about here and got down to about 6 amps. So I don't know if the battery will last long enough for it to get die down completely to zero, to be a complete full charge. Dole, Australian banana. This is a Filipino company that supply America. It's good thing is they're Australian bananas, not Filipino bananas. Alright, it's time to go bang. Normally I would have eaten these being great Australian fruit, but it's been a bit been neglected for too long. And I've got another mess to clean up. But this wiring and everything's more than capable of holding all those, carrying all that charge. So I'm happy with that so far. Let's finish the rest of the banana off. Smells delicious. That's what I call a banana smoothie. That was bananas. Let's make this thing go bananas. Oh yeah, I had the alligator clip there. Oops, zoom. The alligator clip was on the back capacitor, so I was only dumping one capacitor worth of energy into that banana. Now I've got two capacitors connected. I'm going to have the full 2 capacitors worth of energy. This should give me more better results. Alright, get this thing plugged in. 2 capacitors will do it. That banana will need a bit more push to get it to go bang. This is going to go bananas. Charging. Hopefully this will be, I've already connected the banana pretty soon, hopefully. It'll kind of move a little bit. Get the inverter going. 3, 2, 1. Yeah! Yep, that's bananas. That's what I was expecting. That's more like 100, just over 100 kilojoules I was expecting. But unfortunately my, smells good. Carbon flash mix of banana smoothie. It smells kind of like coffee and cigarettes mixed with it. Yeah, disgusting. Anyway, enough for the rifle. You can see my blast shield didn't hold up, and I've got some cleaning up to do. It is shorted out, that's all isolated, but that did protect me and the ZVS, so that thing did its job. Damn, not bad. That went bananas. That's the other one. I don't know where the rest of the first banana is, but that did obliterate the banana, completely obliterated it. Oh, I've got a big clean-up job to do. Okay, yeah. Well, now the capacitors are more than capable of blowing fruit to smithereens. I just got to make up a good containment chamber and blast shield. Now I've got some cleaning up to do now. Anyway, that'll be enough for now. Thanks for watching.